So how do we go about developing an image? So first we have to define what hardware are we targeting. So they've included a little utility called the Target Analyzer Probe, which you run on a Win32 system. Now it can be a full-blown Windows XP, Vista, whatever, or the best thing to do is actually have a Windows pre-installation disk. I'll get more into that later, but basically you boot up, it's a very minimal environment, you run this program, and it dumps out a file with the base hardware. So CPU, architecture, chipset, audio devices, things of that nature. And with that, you then create a custom component based off of that. So that's really the basis for your target device. That's where you start out from. And you can have multiple ones. So you could have one for, maybe like a Celeron CPU or like a Core 2 Duo CPU. And when you deploy the image, then it'll install the appropriate drivers based on the hardware. And then obviously you also need to identify what are you running, what do you plan to run on this device. So are you running Street Deck, are you running Centrifuge, are you running Roadrunner, and what other things do those programs need? So you need to make sure that everything that you need to run for that front end is available. And it can get a little challenging, especially when you're talking about third-party software that may not have a lot of documentation. It gets pretty challenging, because you have to think about not just what the program is directly referencing, but things that it may load at runtime. Things like dynamic DLL loading, COM objects, or Windows management interface. All those things you can't just tell by looking directly at an application from the outside in. So there's tools that we can use to help out on that. This is a little small here, but here I'm running Windows PE, and I'm running the Target Analyzer Probe, so it lists out basically all the base devices. And in this case, I'm running it in a Hyper-V virtual machine. And then with that, you import the file into the component designer, and it creates a component for you. So it looks through the database, and it finds all the drivers that it needs, and then it sets those as dependencies for your component. And then once that's available, again, this is, I apologize, it's kind of small, but it lists all the components that when you pull that component into your target image, it's going to pull all those other components in. So it's going to make sure that at the very least, the hardware devices are supported by your image. Any questions so far?
Is it right to say that Windows Embedded is just like a way to monetize and package up XP as opposed to actually being a separate kernel?
Yeah, it's exactly. It's exactly XP, but they've componentized it, and they've added some extra features that are useful for embedded developers.
Does Microsoft still maintain CE and mobile as well?
Well, mobile is really based off of CE. It's just with the extra, cellular stuff, cell phone support. But Windows CE is essentially what Windows Mobile is running. So they're separate products. When they did the rebranding, everything was called Windows Embedded now. So there's like Windows Embedded. I forget the name for Windows CE, but Windows Embedded Standard 2009 is what XP Embedded is. So once we've got the hardware, again, if we're trying to figure out what software we need, if you have an installer program for like your front end, and you don't have access to the source, obviously, or you don't have access to the developers to give you all the dependencies, there's some tools that you can use to kind of break open an installer program and look at, okay, what is this installer program doing? What registry settings is it configuring? What files is it placing where? So you can use that to kind of help you build a component. And there's a tool from Microsoft called Orca. That's a screenshot there. It's a pretty old tool, but it's still useful. And there's also the Windows Installer XML project on SourceForge, which has some tools that you can basically reverse engineer installer programs. And sometimes, like I said, installer is not always enough. You need to make sure that I properly identified the runtime dependencies. So we can use something like Process Monitor to help us do that. And that'll tell you what file handles, what registry handles, everything that program is doing. So you can run that on like a regular XP system and make sure that you capture everything that you need. And again, this is not always foolproof, so it's going to be an iterative process of going through, building your component, deploying it, testing it, making sure it works properly. So you know, it's not always the most exciting and you know, great thing to do, because it can take a lot of time. And you know, the backup option is just have the installer run as part of the first boot up process. That's an option. It's not the cleanest, because then you're talking about, well, now I need to make sure that the installer program has all the dependencies. Like if you have Install Shield, you got to worry about all the dependencies that Install Shield needs. So when you create your custom components, these are reusable components that are not specific to you. You can share these with other embedded developers, and it's basically just drag and drop. If you've defined your component properly with the proper dependencies, you can basically you know, share that with anyone. You have to ship the binaries, obviously. And it's loaded into your component database, and you can version it so as you make changes or as new releases of like your front-end software come out, you can update it. And then when you open your target image in your developer tools, it'll tell you, hey, I noticed there's a new version. Do you want me to update it? If so, it'll update it and pull in all the new stuff. And like I said earlier, you know, the common steps, you want to bundle the files, define the registry settings, the same thing that Microsoft had to do for their components. And it's also a pretty good way to make easy images. So, you know, for instance, Microsoft has some macro components for like, you know, an internet kiosk or a digital set-top box. Well, you could make one for like Street Deck, right, or whatever other front end. Pull everything in, define all the dependencies that it needs, and then all you need is your hardware component, your front-end component, pull that in, resolve dependencies, and typically you can get to a really good image that way. You'll still need to do some customizations after the fact, but you know, if this is something that you would be doing repeatedly, that's a great way to really make things quicker for subsequent target device. On the Windows Embedded team blog, you can see that, you know, they were basically knocking on every team's door and saying, hey, we're doing this project, you know, please help us out. So hopefully now they're like a, you know, more kind of central citizen, you know, of the Windows embedded or Windows development groups. So this is the target designer. So here's an example of, unfortunately, I don't know if you can see this, but they have some what they call like test or test development type helper tools, and in this case they have a Virtual PC 2007 macro. So this just saves you the time of running that tap tool that I was talking about earlier. You know, so if you're testing this on Virtual PC 2007, you can just pull this in, and it sets up all the base hardware devices. And on the left, it basically has a big tree tree view of all the components available, and you just drag and drop. And you know, you can do resolve dependencies, and it will basically go through all the components and look through all each component's dependencies and pull those in. You need to be very careful though if you do this, because if you pull in something like Internet Explorer and do resolve dependencies, you're going to bloat your image like you just can't imagine. And you can't just do undo. You can't just, you know, hit Control Z and roll back. Unfortunately, they didn't have that. So you have to be very careful. And there's different filters. You know, this and the default level, it's pretty like high level. So it shows you, you know, the kind of like the high level components. And you can filter all the way down where you're actually dragging in like the, you know, keyboard driver, you know, serial mouse driver. I mean, at that level, that's probably far too lower than you really need to go.